All right. So we are discussing 4.3. 4.3? 4.4? Because I think for most of us, we need 100% of his homework. That's 50 points, isn't it?
We're turning in tomorrow.
Yes. Were you here 5 minutes ago? Or 1 minute ago?
Yes.
Yes. Well, you don't have to hand it in and see what a 0 out of 50 does to your grade. I think a 0 out of 50 would... Wait, how many total points are there? Let me think. So, let's see, your grade would go down 8%.
8?
If you get a 0 out of 50.
Oh, but we're not going to get a 0.
Well, if you don't hand it in.
Oh!
0. Okay, let's do this quickly. Maybe we can finish early. Number 5. Y. All you have to do is compute the derivative. Come on!
Wait, you know this one tomorrow, right?
No, the quiz is only on 5.1, 4.1, 4.2. You're just going to have to wait for the test to get tested on this. Okay, so have we memorized the derivatives yet?
1.
You're lucky this is not on tomorrow's quiz.
1.
The derivative of sine inverse box is 1 over the square root of 1 minus box squared times the derivative of box, which is, this is like 3t to the negative 2. Negative 6t to the negative 3. Okay, that's correct. Okay, but now you gotta simplify this. That's the problem. It's always the problem. So this is like 9 over t to the 4th, correct?
Yeah.
So if you make a least common denominator in the radical, which is t to the 4th, you're gonna have t to the 4th minus 9 times negative 6 over t cubed. Now this t to the 4th can come out of the radical as, what is the square root of t to the 4th?
T squared.
T squared. It's actually absolute value of t squared, but no need absolute value because t squared is always positive. And then what happens when I multiply this t cubed times this denominator there? That t squared is going to cancel into the t cubed, so you're just going to get
T.
So here, I'll go over here. So you're going to get negative 6 over t times the square root of t to the 4th minus 9. And there you go. All right, number 6. See, like already, like this, tomorrow, if you get this many questions, there's no way you're going to finish, you're going to hand it in, some of you are going to get bad score. Number 6. I'm just going to use x's instead of s's here. X, because that's what I'm going to do. X squared plus cosine. Just make sure you get the first step, because at least you get half the points, right? So what prime equals, now, did you guys rewrite this as to the 1/2 power? Do it if you have to, and then you have to use the product rule because it's a product, right? So derivative of the first, leave the second one alone, plus leave the first one alone, and how do you take the derivative of box to the 1/2? 1/2 box to the negative half times the derivative of box. See, do not forget to multiply by derivative of box, that's going to be a fatal error there. And then, what's the derivative of cosine inverse x? Negative 1 over root 1 minus x squared. And when is the test on this? When you come back, yeah? When we come back on Wednesday, I believe. Yeah, you're going to have a substitute teacher on that one. So, what do we have? Root 1 minus... Now, if you have hard time simplifying, change everything to radicals. Minus, the 2's cancel out here, so you get x squared all over root 1 minus x squared minus 1 over root 1 minus x squared. So what's the least common denominator for these three fractions? Here, I'll put it over 1 if you need to read it. Root 1 minus x squared, and then on the top can be 1 minus x squared minus 1. The 1's cancel out, and what do you got? Negative 2x squared all over root 1 minus x squared. And you can't really do anything with that, so that's the answer. 7. 7 looks almost the same as this one. Y equals x sine inverse x plus 1 minus x squared to the half. So again, you gotta use the product rule right here. Derivative of the first, leave the second one alone, plus leave the first one alone, and the derivative of sine inverse is 1 over root 1 minus x squared, plus, this is box to the half, 1/2 box to the negative half times the derivative of box. Did we get that? Okay, so we got sine inverse x plus x over root 1 minus x squared. This one, the 2's cancel out, so you get negative x over root 1 minus x squared. Hey, they cancel out. There's your answer. That one was a good one. Yeah, when we get to the test, oh, I got some really good problems that simplifies really nice. Unless, of course, you don't, your algebra is all off and it will come out ugly. Number 8. Y equals 1 over sine in, now this one, the simplifying is not very good. But they just want to see what if you know what you're doing. Isn't this the same thing as sine inverse 2x all to the negative 1 power? Yeah, you probably want to write it like this so that you can see that it's box to the negative 1. So, what is the derivative of box to the negative 1? Negative box to the negative 2 times the derivative of box. Now, so this is like a whole new problem. This is like box within box again. What do I see in the box? Sine inverse box. What's the derivative of sine inverse box? 1 over the square root of 1 minus box squared times the derivative of that box, which is 2. And there's not really much you can do with that. Like, you can simplify that to 4x squared, but that's pretty much all you can do. So, nothing special about that one.
I have a question.
Mm-hmm.
Sorry, how come it's not like how come you can't change to like cosecant to it? Cosecant inverse to it? Because if it's a 1 over.
Because you can't.
Oh, okay.
Okay, 1 over sine is cosecant, but 1 over sine inverse is not cosecant inverse. That's called making up your own. That would be,
Okay.
yeah, that would be a fatal error there. Yeah, cosecant and sine are reciprocals of each other, but not the inverse. Not the inverse. All right, 15. Okay, compute the derivative. Come on. Y equals cosecant inverse x squared plus 1 with a restriction. Of course, what is the restriction for again? So that you don't need to worry about absolute value. So derivative is equal to, now have we memorized this? Do I have to test people? No. Negative 1 over the absolute value, think of this as box, absolute value of box, times the square root of box squared minus 1 times the derivative of box, which is 2x. Now the only thing you can really do here is you don't need the absolute value because it's already positive. And yeah, there's not much you can do. That problem is not, see, I wouldn't give something like this on the test because I want to put something on where it's going to simplify. So that one, I mean, it's good to practice the derivative, but you're not going to see that one on the test. 17. Why? Isn't this the one I did? Which is the one I did? Secant inverse 1 over t. T is between 0 and 1. Okay, you want to do it the long way or the short way?
Short way.
Okay, the short way. Now, secant inverse 1 over t is the same thing as cosine inverse t. You guys remember doing a problem like this last night? See, because if you simplify to that, then look, the derivative, you just regurgitate. Negative 1 over root 1 minus t squared, finish. Whereas if you kept it like that, then you're going to get the same answer, except you're going to do like 5 lines of work. Number 19. What do we got here? Y equal cotan inverse root t minus 1. So, what is the derivative of cotangent inverse box? Negative 1 over 1 plus box squared. What happens when you square that? You just get t minus 1, right? Times the derivative of box. 1/2 box to the negative half times the derivative of box, which is 1. So this one, the simplifying is not great either. Negative 1 over, the 1's cancel out, so that 2t, and when it's negative half, it means it's like in the denominator. So I guess it would be that. Nothing special about that. No, for real, wait till you see the ones I put on the practice test. Yeah. Those are really good. No, you guys don't even know. You know, you don't know. Y equal root x squared minus 1 minus secant inverse x. And they didn't give a restriction. I'm guessing x got to be greater than 1. Don't worry, I will give you a restriction so that you don't have to worry about the absolute value. Because, right, secant inverse and cosecant inverse, that's when you have the absolute value in there, right? So, y, I gotta call on people. You guys gotta know this. Chong!
Half s squared minus 1 to the negative half. X, yeah. Times 2x
Okay, that's fine.
minus 1 over x square root x squared minus 1.
Okay, that's correct. It's supposed to have absolute value, but because of this restriction, no need, yeah? Okay, now just gotta simplify this. The 2's cancel out, so you have x over, change everything back to radicals if you have a hard time simplifying. It's a lot easier. Now you can clearly see the least common denominator is x root x squared minus 1. So this one you gotta multiply top and bottom by x, so you get x squared minus 1. So your final answer going to be root x squared minus 1 over x. Box that, that's the answer. You guys see what I did? It's called algebra 1. Look, isn't this like x squared minus 1 to the 1? Isn't this one here like x squared minus, this is like separate, x squared minus 1 to the half. What do you do with the exponents when you divide? You subtract the exponent, so that's why you just get x squared minus 1 to the half, which is square root, right? This is algebra 1. Look, you guys understand everything but the algebra 1. No, you have to know this because you gotta pick out the answer on the multiple choice, you know. Because I guarantee you, whatever answer you get, that's not the one there. You're gonna have to like low me it until you get it. Find an equation of the tangent line. Come on! 25? This is an insult. At x equal 3. Now what are the two things you need to write an equation of a tangent line? Point and a slope. So what's the point? 3 comma. What happens when you plug in 3? You get sine inverse 3/4. You can either, now that's not a number we know. Like if it was sine inverse 1/2 or root 3 over 2, we would know it, but 3/4 we don't know. So you either leave it like that or take out your calculator, punch it in, and leave 3 decimal places. What do you want to do? I would just say leave it, yeah? Because then you don't have to take out your calculator. Now to figure out the slope, you got to compute the derivative. What's the derivative of sine inverse box? 1 over the square root of 1 minus box squared times the derivative of box. What is the derivative of box? Go. That's what happens. You don't pay attention. You know I'm going to call on you. Just look, I circled that. What's the derivative of that? X over 4.
Or 1/4.
Yeah, 1/4. Because isn't that the same thing as just 1/4 x?
Yeah.
You know, because the other class, they want to use the quotient rule on this. No, and it works, but why do you want to do that? Look, quotient rule, low d high, right? Minus high d low, all over denominator squared we go. That's 1/4. But why? That's the same thing as just 1/4 x. Okay, and then how do you actually compute the slope? At this point, you have to take the 3 and plug it in here. Can we do that? Let's see if we can do it in our head. What is 3/4 squared? You already did right, it's 9/16. Subtracted from 1.
7.
So 1 over, so basically you got 1 over the square root of 7/4, yeah? Which is 4 over root 7 times 1/4. The 4's cancel out, you get 1 over root 7. So then just do point slope form. Y minus the y coordinate is equal to the slope times x minus the x coordinate. See, it doesn't matter how ugly it is, you just do it. And then finally, 29C. Oh! Okay, this problem is on the test now. How many people got it?
I don't know.
One person got it? Tanaka? How did you figure it out?
I did it. This looks
You just did it.
yeah. This looks, or they're like,
Wait. Okay, this is the way I'm going to state it on the test, okay, 29. I'm going to give you a function, cosine x plus 3x. In fact, it's on the practice test.
oh, I watched the video.
Oh, so it's on the video.
Yeah.
So what about the rest of us? Anyway, okay, so this is what I'm going to ask you. What is f inverse prime of what number do they want? F inverse prime of 1, it says. Okay, I'm going to show you how to do this, and usually it takes 2 or 3 times before you get it now, so hopefully you learn it. Now just do what I'm showing you. It's not that difficult. But before we do that, let me explain something. Let me erase this. Because this is on the AP exam every single year. So if you know this problem is on there, just to make sure you can get it. Now, what did we learn from Algebra 2 and pre-calculus? If you have a function and it's inverse, aren't they always symmetric about the line y equal x? Now, if you have a point on the function, let's say it's 4, 1, what would be the corresponding point on the inverse? 1, 4, right? You just switch the x's and y's. Now, is there a relationship between this slope and that slope?
Same.
Yeah, just look at the picture. Like for example, if this slope is 2/3, just by looking at this, what's the slope of that one? What? 3/2. It's the reciprocal, not negative reciprocal, just the reciprocal. You see why? Because it's got to be symmetric about this line, that's why. You guys see that? Or just memorize it, it's the reciprocal. So, we have 2 functions. We have f and the inverse. Okay? Now, we're trying to find what is the slope of the inverse when x is 1. So in other words, on the graph of the inverse, when the x coordinate is 1, we're trying to find the slope because that's what the derivative tells you, right? The slope. That's what we're trying to find. But that's very difficult. So what we do is we go back to the original function. Well, if on the inverse, the x coordinate is 1, what can you say about the y coordinate here? It's 1 because you've got to switch the x's and y's. Right? Okay, now this is the hardest part of the problem. Here is the function. What do I need to plug in for x to get 1? And usually it's going to be some easy number. It's not going to be something where you have to think too hard. Okay, I heard 0. Is that correct? If I plug in 0 for x, do you get 1?
Yeah.
Yeah, you get 1 plus 0, 1. See, it's going to be a nice number. If it's not a nice number, then the problem's going to be too hard for you. So they always make it nice. And then over here, can you figure out the slope? How do you find the slope of a graph? You take the derivative. What's the derivative of cosine x plus 3x? Negative sine x plus 3, that's right. So what is the slope at this point though? If I plug in 0 for x there, what is sine of 0? So 0 plus 3? So it's 3. Therefore, what is the slope on the inverse function? 1/3, that's right. It's the reciprocal. So your goal is to get this slope and then just reciprocatize it to get the answer. Can you repeat this on the test? Well, you're gonna have to. I'm telling you right now, it's on the test. Probability 1, here. Probability equal 1, it's on the test. So there is 1 on the practice test, make sure you do it. Okay, so that's it. So tonight, all you have to do, this is the last section in chapter 4. So we need to finish the list. So did you guys look at the website yet? On the left side, there's a list of derivatives. Did you guys find that now? You guys should probably click on it and like print it out, or make sure it's easily available.
What is our speed quiz on it?
I don't know, maybe we might not need one. Well, it doesn't, I don't think we're gonna have one. Yeah, I don't think we're gonna have one. Or maybe we will. I don't know. Okay, so in addition to all the derivatives we learned so far, today we're gonna add these 3. E to the x. Maybe we should just go e to the box. E to the box. Natural log box. A to the box. Actually, I should put this one up there. A to the box. Natural log box. And actually, there used to be one more. Log base b of box. But I'm going to show you that you really don't need this one, so that's why I took it off. Okay, you know what? In the interest of time, why don't I just tell you, so you don't have to worry about the derivation. Okay? The reason why e is such an important number in mathematics, the reason why you were taught it in Algebra 2 and in pre-calculus, is because the derivative of e to the box is e to the box. The derivative of e to the x is e to the x. There's only 2 functions in the world where the derivative is equal to itself. This is one of them. What's the other one? Can you think of a function where you take the derivative and you get itself? There's only one other one. Somebody said x. Well, the derivative of x is 1. So okay, let's try that. 1 over x. The derivative is negative 1 over x squared. No. Think easy.
0.
That's right. The derivative of 0 is 0. We call that a trivial case because. But the derivative of e to the x is e to the x. That's why e is such a special number. So, in the general case, if you have e to the box, is the derivative just e to the box? No, the chain rule says you gotta multiply by derivative of box. That's the chain rule. Now what about a to the box? Here, you know what, I'll just tell you. A to the box times natural log a times the derivative of box.
Wait, what is A?
A is a number, like 2 or 3,
Oh.
5. And then natural, see, these 2 are like the 2 easiest derivatives there are, because natural log is log base e. The derivative of natural log x, we're not going to derive this, but is 1 over x. Pretty darn nice, yeah? So in the general case, if you have natural log box, is the derivative just 1 over box?
No.
No, you got to multiply by derivative of box, by the chain rule. And we'll just save that one for later. Okay, so let's do some examples. Like, what kind of problems are you going to see for this? All right. Let's start off easy. Y equals x squared e to the x power. No, let's kick it up a notch. 3x. Compute the derivative. Now tonight there's a whole bunch of problems. It looks scary, but it's really, all you have to do is take the derivative. It's easy. So this finishes our list right here. How do you take the derivative of this? Well, I see a product. I gotta use the product rule. So derivative of the first. Okay, and then what do I see here? E to the box. We just learned it. What's the derivative of e to the box?
Function?
Oh, no, never mind. Derivative of the first, leave the second one alone. You leave the first one alone. Okay, now, what's the derivative of e to the box?
8.
E to the box times the derivative of box, which is?
3.
And put 3 in the front. We don't want to put it there. And there you go. That's the derivative. And of course, you need to simplify it because next chapter we're going to make number line for this. So what can I factor out? Look, I got two terms here. What can I factor out? An x and an e to the 3x. What's left?
2x. But that's just
2
you.
plus 3x. So if you were to make a number line, I'm not going to make you do it now. Or maybe I will. You got to look at the practice test. What do I put on the number line? What makes that 0? 0. What makes this one 0? Negative 3 over 2 or 2 over 3? Negative 2 over 3. What would make that 0? Nothing. E to the something is always, look at the graph. E to the x is always above the x-axis. It's always positive. E to the something power is always positive. So basically when you make your number line, it's just like it's not even there. So then you just go plus minus plus. That's what your number line would look like. Yeah.
If it's like e to the negative box. then-
Yeah. So like e to the negative 2x, it's also always positive, right?
Oh, okay.
Because the graph of e to the negative x looks like this. It's always above the x-axis, so it's always going to be positive. E to the something, no matter what, is going to be positive. Okay, let's do one with natural log. How about y equal x, natural log x? How do I take the derivative of that? You know what? I changed my mind. I'm going to go natural log x over x. We already did product rule. Let's do a quotient rule. Well, I see a quotient. I'm going to use the quotient rule. So low, d high. Now what's the derivative of natural log x right there? The derivative of natural log box is 1 over box times the derivative of box, which is 1, right? Low d high minus high, what is d low? 1. All over denominator squared we go. And you get x times 1 over x is 1 minus natural log x over x squared. In fact, I'm doing a problem for you from next chapter. Okay, and then if you were to make a number line, just for fun, what would go on the number line? What makes the bottom 0? 0. What makes the top 0? See? That's what? Algebra 2. E, very good. E. What? Because what is natural log of E? 1. 1 minus 1 is 0. So what you need to know is natural log E is 1. What is natural log 1? E to the what power equals 1? 0. You need to know like these basic things. Okay, let's go one more step. Let's find the second derivative. No, that's what you're going to do with the homework, on the test. You got to be able to compute first and second derivatives. Well, here's the first derivative, which is a quotient. So when I compute the derivative of that, you got to use the quotient rule. Low, d high. Now, what's the derivative of that? So the derivative of 1 is 0. Negative, and what's the derivative of natural log x? 1 over x. Low d high minus high d low. What is d low? 2x. All over denominator squared we go. So that's going to be x to the 4th on the bottom. But you know what the hard part is? You got to simplify it. So you got negative x minus, this 2x got to be distributed now. Minus 2x plus 2x natural log x over x to the 4th. Hey, this looks like something from my test. So you get 2x natural log x minus 3x all over x to the 4th. What can I factor out in the numerator? It rhymes with mex. 2 ln x minus 3 all over x to the 4th. But can I cancel this x into one of those x's? And so you just get 2 ln x minus 3 over x cubed. Yeah, there you go. That's the simplified form. And then just for funsies, if I were to make a number line, what would go on this number line? What makes the bottom 0? 0. What makes the top 0? Okay, think like what we did over there. Okay, e to the very good, e to the 3/2 power. What? Okay, look, if you don't know, go on the side. Look. 2 ln x minus 3. When is that 0? When 2 ln x equals 3. When ln x equals 3/2. How do I get rid of a natural log? You e both sides. E to the natural log x is x, and that's how you get e to the 3/2. But you don't have to worry about this till next chapter. This chapter, you just worry about getting that. You don't. We're going to make number lines next chapter. So we did one product rule, one quotient rule. Okay, so what about this rule? Now what is this a? A is a number that's not e. You know what I'm talking about? Like 2, 3, 5, pi, square root of 7. Any number that's not e. So here, something like this. What if you have y equal 5 to the sine x power? How do you take the derivative of that? Well, if this is a constant, see, a is a constant, a is a number. So whenever you see something that looks like this, you're going to use this rule. I call it the a to the u rule. So just follow it. It's easy, just regurgitate it. So what's the derivative? You just follow. A to the u, so a to the box really, so 5 to the sine x, times, what's the next one? Natural log a, this is the a, so natural log 5, times the derivative of box. Cosine x, there you go, that's the derivative. It looks ugly, but that's what it is. So you guys understand when to use, see that's the key to doing these derivatives, is you gotta know when to use which rule. So here, let me break it down for you. What if you had y equal x cubed? To take the derivative, just leave it on my desk. Can I just put the power in the front and reduce the power by 1 like that? Yeah. So when you have x to a number, see how in the exponent is a constant? Then you can just use the power rule. Okay, but what happens when you have 3 to the x? Can I just put the power in the front and reduce it by 1? No. No. You only can do that when the exponent is a number, when it's a constant. Over here, the base is a constant. So this is a polynomial function. This is an exponential function. You cannot do this. Although when you do the multiple choice, that's going to be one of the choices, and please don't pick that one. So what do? You use this rule, the a to the u rule. So what's the derivative? 3 to the x times natural log 3 times the derivative of x, which is 1. Easy. And then you got this one. What if you had x to the x power? How do you take the derivative of that? Well, is this a number? Is that a number? What happens if neither is a number? See, if that's a number, you use this rule. If this one's a number, then you use this rule. But if neither is a number, you can't use either rule. So we have to do something else. Did anybody read ahead? Tanaka?
No.
You might read ahead. You have to use this technique that's called logarithmic differentiation. So I think only the problems at the very end, you're going to use logarithmic differentiation. Do not use any of these two other rules because that will be completely wrong. So let me show you how logarithmic differentiation works. What you do is you do exactly what it sounds like. You natural log both sides. Natural log y equals natural log of x to the x. Now, why do you think we natural log both sides? Because what did we learn in Algebra 2 and pre-calculus? When you have a logarithm, what can you do with this power? Put it to the front. See, but you only can do that if there's a natural log there, so that's why you natural log both sides. So this power comes to the front, and then now can I do implicit differentiation, which is what you get quizzed on tomorrow. Yeah! So now you do implicit differentiation. What's the derivative of natural log y? 1 over y times the derivative of y, which is y prime, or if you want to write dy dx, whichever one. And then on the right side of the equation, hey, that's a product, I gotta use product rule. Derivative of the first, leave the second one alone. Leave the first one alone, what's the derivative of the second one? Natural log x. 1 over x times the derivative of x, which is 1. So, to solve for y prime, all you have to do, how do I get rid of a 1 over y on this side? Multiply it by y. Multiply both sides by y, and you get natural log x plus 1. Now, if you left your answer like that, I would give you full credit on the test. However, on the AP exam, you're going to have to substitute for y. What can I substitute for y going back to the original? X to the x. That's the way it's going to be written, and you got to pick out the answer. So, like I told you, so when you're doing tonight's homework, you got to know when to use each rule. So like, what if I give you this? Y equal x to the radical 2. Can I put the power in the front and reduce it by 1?
Yes.
Yes, because that's a number. You guys get it? It's a number. Then that's when you can do it. What about if you saw this? Y equals pi to the tangent x power. Which rule do I have to use for that? See, just because it looks weird, doesn't it? That's the a to the u rule. So what's it? A to the u times, it's right there, natural log pi times the derivative of tan x, which is secant squared x. And then, what if you had something like this, and you are going to have, I think one of tonight's homework problems is sine x to the x. Can I use one of these first two rules? No. When neither this nor that is a constant, the only way you can take the derivative is natural log both sides. Okay, now, last thing, and we're done. This one right here. It used to be on our list, but I took it off the list because that's just one more thing to memorize. And already, for real, every year students, for some reason, an A to the U1. This is the kind of mistakes they do. Like, what if you had 7 to the natural log x power? Okay, so this is the A to the U rule, right? So what is the derivative? 7 to the ln x times natural log 7. But every year, I don't know why, students put ln x. No, it's natural log 7 times the derivative of the box, which is 1 over x. Yeah, I don't know why, but every year it's for some reason. Okay, but the one I want to show you is that last rule. We're not gonna. So what if you did see a log that's not a natural log, like here, log base 3 of x squared? Any ideas? No.
You do like the division rule, where you can take the natural log of x squared divided by the natural
Oh
log.
yeah, exactly. That's called the change of base formula. You guys remember change of base? Okay, so how do you change any logarithm to natural logs? You go natural log x squared over natural log 3. And it's easy to remember the change of base because the top one goes on the top and the bottom number goes on the bottom. Does this look familiar? And then now use the quotient rule?
Yes.
No, I mean you can, but that's a constant. Natural log 3 is, you could punch that in a calculator, right? You get a number. This is a constant. Throw it on the side like an unwanted pet. Yeah. I mean you can use the quotient rule, but why? It's just like, do I use the quotient rule on that? No, that's the same thing as 1/4 x. Same thing like this. So now I can take the derivative. So this constant, throw on the side. What's the derivative of natural log box? 1 over box times the derivative of box, 2x. That is correct. Then I'll need to simplify. All you can really do is cancel that x into one of these x's there. It's like, oh, Mr. Park, could I have done this? 1 over natural log 3 times, Mr. Park, since I have a power there, can't I put the power in the front since it's a logarithm? So I can take this 2 and put it in the front, so it goes here times ln(x). So when I take the derivative, this is a constant, you throw it on the side. What's the derivative of natural log x? 1 over x. Is that the same answer as this? Yeah, it is. See how if you do correct mathematics, it doesn't matter. It's gonna come out. So that's why I don't put this on the list anymore. If you see a logarithm that is not natural log, just change base to natural log. It's easy. Okay, so this is it. This is the list of all the derivatives you need to know for the AP exam. So I listed it on one big list. It's on the website on the left side. It says list of derivatives. These must be committed to memory, otherwise you cannot pass the AP exam. All right, we're done. So what do you need to do tonight? The practice. What about the homework though? Oh, you want me to just collect the homework for next time? I can do that if you want.
Yeah.
Oh, but then you get more points there.
But then we don't.
Yeah, there's 10 more points. It doesn't matter that much, right?
Yeah, can you call?
Okay, we're gonna make a decision right now. Save 4.4 for next time, or discuss it tomorrow.
Next time.
To get more time.
Yeah.
You're gonna have 55 minutes for a 20-minute quiz.
Yeah. Because we're AP, right?
No, but the quiz is already. Plus, I'm giving you a quiz that's just like it. Okay, that's okay. I'll do it. So you're only gonna hand in 4.1, 4.2, and 4.3.
Yeah.
All right. I'll go with that.